Hello, guys. This is Mrs. Berg. Hope you guys are doing okay. Um, we are going to be working through the first lesson of the next unit, and wanted to um, I wanted to remind you that everything's going to be online. So obviously, this video will be online, as well as the keys to everything. So the keys to the practice and the keys to the notes. I'm going to put everything online for you guys. So if you want to check anything, you can do that. Okay. Okay. So the first thing that um, I want to talk to you guys about. So here's the learning goal. So here's what we want to talk about today. What are some methods for solving systems of equations algebraically? So we're going to start talking about what a system of equations is, how to solve them algebraically, and then maybe talk about a little bit which method is the best here. So first and foremost, this is review from what you guys have done in the past. So if you remember that linear quadratic systems can result in three kinds of graphical situations. So what happens is, first of all, what is a system of equations? When you have two or more two or more graphs in one coordinate plane. And what happens is when you have two or more graphs, sometimes they intersect. And when they intersect, that's what we call a solution. So this particular graph here has two solutions. This corner grid here has one real solution because they intersect only once. And this one has no real solutions. Keep in mind that I'm saying real solutions, right? So they could be imaginary, but this one doesn't have any real solutions. Now, that's one way of finding solutions of systems. We also have algebraic ways. Okay, so now I want you to keep in mind the linear quadratic systems solutions graphically. Keep those in mind. But now I'm going to talk about how to solve them algebraically. And you might remember this from last year. So the first method that we're going to talk about today is called the substitution method. It's called the substitution method. Okay. Now, we're going to deal a lot with word problems in this unit. So we do have to know how to also, you have to take this from last year, you have to know how to translate from word into algebraic expression. That's very important in this unit. So for example, let's take a look at some problems together. The perimeter of a rectangle is 48 feet. So I know I'm talking about a rectangle here. So I'm going to take a minute and I'm going to actually sketch a rectangle. Okay, let me do a better job here, guys. Sorry, I'm working with a tablet. It's a little hard to draw. Let's try it again. Okay, it's a little bit better. Okay, so what do we know? Everybody knows from geometry, the perimeter is the sum of all the sides, and a rectangle has opposite sides, two sets of opposite sides that are congruent. Okay, so I know that the perimeter is going to be when I add up all the sides, it's going to be 48. And I know that the area is going to be 80 square feet. Now, what I want to know is I want to find the dimensions of the rectangle. Dimensions are the length and the width. Okay, so length and width. That's what I'm looking for. All right. Now, let's go over here and visualize it. So if I call this the length, these guys are the L, and then we're going to call this the width. Why am I doing two? Because opposite lengths, opposite sides are congruent in a rectangle because it's a parallelogram. Okay, so now if I think of the perimeter, what is the perimeter? Perimeter would be if I add up all the sides, right? So if I go here, I think, okay, well, the perimeter of this particular shape would be 2y or 2x plus 2y. Oh, sorry. No, we're not doing x and y here. We're doing l's and w's. So we're going to call it 2w's plus 2l's. Right? So if I add up all these sides, that's what I get. And how would I find the area? The area of a parallelogram, it's length times width of any parallelogram. Okay? Or base times height, however you want to call it. So in this case, it would be L or W times L. Or L times W. It doesn't really make a difference. Okay, now the cool thing is that I actually know what the perimeter is going to be, and I know what the area is going to be because they told me. So let's go back to this side here. So I know that the perimeter is 48, so I can actually set up two equations to kind of help me think about what I'm doing. Okay, so you always want to have equations. You're always going to you're going to write equations that model what you're looking at. So I know the perimeter is 48. Oh, okay, so now I know that 2W plus 2L is going to be 48. That's the first equation. And then I also know that the area is going to be 80. So I know that L times W will be 80 because that's the measure of the area. Okay, so now what I want to do, here's the substitution piece. What I want to do is I want to look at these two equations and try to isolate an L, one of the variables, right? So it said L equal to itself or said W equal to itself. Why? Because then I can take that expression and substitute it back into the other one. So what you want to do is you want to look at both of these. Which would be the simplest one to isolate? Well, if I do L times, if I take this guy here, let's see, if I take this guy here, and let's say that I want to, and it doesn't really matter which one you isolate, you would get the same answer. But if I try to isolate the x, let's say, or isolate the w or the l. Let's isolate the x. So if I do that, the x, I said it again. Isolate the w, this guy here. So I just have to do a little bit of algebra, right? So I'm going to go over here. I'm going to say, okay, well, let's see. 2y plus 2l is 48. Okay, so now I notice that they all have a common factor of 2. So I'm going to do that. So then I get w plus l is 24. And then I simply have to just subtract l from each side. So then I know that w is going to be 24 minus l. Okay? Now what I can do is the following. I can take this, whatever w is, this expression, and I can sub it back into here. Because these two w's are the same. They both represent width. So then what would that look like? It would be L times 24 minus L equals 80. Now this is really cool because I only have one variable. I'm not working with two anymore. I'm only working with one, which is what you want. You only want to be working with one. So when I look at this, I go, okay, well, I'm going to distribute. Here we go. L times 24, 24L, and L times negative L, negative L squared equals 80. Oh, look at that. I have a quadratic. Okay, so I know how to work with quadratics. I'm going to set it equal to 0 and then see if I can factor. I'm going to play around with this algebraically a little bit, and it's going to end up looking like what? So I'm going to bring, I want L to be positive, so I'm going to bring this guy over here. I'm going to add L2 and then minus 24L, so I end up with L squared minus 24L plus 80 equals 0. Okay, so now we know how to work with this. This is a quadratic. Now you're going to try some factoring methods, and sum and product work nicely here. So we're going to work with sum and product. So it's going to be L. So two numbers, salt and pepper, two numbers that multiply to give you this and add to give you this, right? So we're going to try, let's try minus 20 and and minus 4. Oops, L minus 4. Okay, so now let's solve for L. So many equations here, and L is 20 on this side, and L will be 4 on this side. Okay? Now, if this is, we want the dimensions of the rectangle, so we have the lengths, now we have to solve for the widths. So if L, so that's why I made a little, I separated this here. So we have two solutions, so we can find the widths for each of the solutions. So what was the width again? Oh, the width was 24 minus L, right? So we're going to go back here and say, okay, well, I know L, so the new width, the width is going to be 24 minus 20. So the width here would be 4. So when the length is 20, the width is 4. All right, let's go to the other side. Same equation, right? And it really doesn't matter where you plug it back in. You could have plugged it back into here too, or here, because these are all true equations, right? So, but usually so you try to look back and see which is the nicest one that will give you the other variable. To me, this one looked simpler, so that's why I'm using that one. So what would be the width here? So what do we have? We have 24 minus 4, so then the width would be 20. Now look and see what happened here, right? So they flip-flop. So if my length is 20, the width is 4. If my length is 4, the width is 4. So what the dimensions of the rectangle must be then what? They must be 4 foot by 20 foot. Doesn't matter which way I look at it, it's always going to be this. 4 foot by 20 foot. Okay? Let's take a look at another example. Okay, so I'm going to take you through these guys because they're all each a little different. So we're going to look and see how we can solve them. Okay, so for something like this, it's a system. So you have two equations here. And what I want to do is I want to look and see, it's the same type of idea, right? We want to isolate a variable, either x or y, and then what we can do is we can substitute it back into the equation, right? So we want to solve one, and what works here is you can do x or y, but the best thing here is to look at the equations and see what's the best algebraically, what would be the best thing to do here. Can I substitute this x into here? Sure, but take a look at this equation, right? It doesn't really look that nice. Can we try to make it look linear? Let's try to make it look linear because then it will give me a better idea of what I'm working with here. Okay, so now how do I make this linear? Well, I'm going to multiply each side by x squared minus 9. Right, so I'm going to take this whole equation here and then I multiply it by x squared minus 9. Why? Because then look at what happens. This is not going to be a fraction anymore, right? So if I multiply this by x squared minus 9 on this side of the equation, then I'm just left with y equals, and then on the other side, if I multiply x squared minus 9 times 1, I get x squared minus 9. Okay, and now I'm left with that, and now look, I've already isolated the y here. Look and see can I make this also look like a y equals equation? I could, right? So if I add the 3 to both sides here, then I would have y equals x plus 3. And look, now I have two equations that equal y. So in other words, they equal each other. Remember the transitive property? So if y is equal to this and y is equal to that, then these two must be equal to each other. And that makes my life so much easier. So I'm going to go here. I'm going to say, okay, well, x squared minus 9 equals x plus 3. And now I have an equation that will help me solve for x. All right, so now let's go ahead and solve for it. What are we going to do here? So we're going to move this x and this 3 over. So then I'm left with x squared minus x minus 12 equals 0. And now I'm going to check to see if I can factor this. I can using sum product. So it's going to be x minus 4, and it's going to be x plus 3 equals 0. And now I'm going to solve each of them separately. So x is 4, and x is negative 3. Okay, so those are our two solutions for x. This is my first x, and that's my second x. Now these x's will then yield different y's, right? So now what I do is I plug it back into either of these equations. It doesn't matter which one. Why? Because when I find the solution is going to work for both of them. So it doesn't matter which one I use to get my other coordinate. right? So this is a nice and easy one. I like this one, right? Y equals um, x plus 3. That's a nice one. So I'm going to come over here and say, okay, well, if x is 4, then what would y be? Y has to equal 4 plus 3, which is then 7. So these are the coordinates, the first coordinate. So I have x equals 4, and then y will be 7. So the first point here is going to be 4 comma 7. That's the first solution. All right, let's work with this guy here. Move it over a little so I have more room. So same equation, right? I can go back and use this one. Y is equal to, what was my x? Oh, the second x here was 3. So 3 plus 3 will be 6. Oh, this should be negative 3, sorry. That's why it looked a little funny. Okay, so now let's look for a second. Let's stop for a second. If I look at the solution, I can always check to make sure that, I'm going to go back and I'm going to make my check right here because I told you guys to check. So the only thing we have to watch out for is the following. And I'm going to come back to this in a little bit. I want everyone to take a look at this equation here. Do you guys see how this is a fractional equation? This is a fraction on the bottom. The only thing we have to watch out for that, and this is something that you guys have to remember, is that when you have a fractional equation, the denominator can never be 0. And the reason for that is because if it's 0, then it's going to make the fraction undefined. And that's an error. That's not going to work. So if one of your solutions, if you can catch this before the check, then you've saved yourself some work. That's why I'm telling you guys to do it now. So I noticed that this was negative 3. Take a look. When I plug in negative 3 into this equation, then into x, then negative 3 squared will be 9. What's 9 minus 9? Uh-oh, that's 0. So then I know, before I can even check my solutions, which we will in a little bit, I know that this is not going to work. I know that's not going to work. So what I'm going to do is I'm going to reject it right away. Why? Because it makes the fraction undefined. Now, what if I didn't catch it right away? Well, then you would have seen it here when you check, right? So I'm going to go ahead and I told you guys to check. So let's check. Okay, well, let's see. What do we have here? We have, so where's my point of solution? My solution is here. So 4, 7. So what I want to do is I want to make sure that that solution point works for both of my equations, right? So it doesn't matter which form. You can look at it in this form or you can look at it in this form. It doesn't make a difference. So my first equation was y equals x squared minus 9. And the second was y equals x plus 3. All right, so now let's see if this works. I'm going to substitute, this is x and this is y, so I'm plugging it back into the equation. So is 7 equal to 4 squared minus 9? So is 7 equal to 16 minus 9? Oh, yes it is. So then that works for that equation. That solution works for this one. How about this one? Well, I don't know, let's check. It's 7 equals to 4 plus 3. Yes, it is. So then that checks out too. Okay, so if I ask you to check, you should always be checking there. If I had checked this point, you would have seen it wouldn't have worked out. So that's a way to kind of, keep yourself check your work. So for this one here, I don't want you to check it. Now, what you should look at this, and you haven't done this in geometry yet, but this is actually a circle. X squared plus y squared equals 9. That's the equation of a circle. And this is a line. So graphically, it would look like a circle and a line. And I want to know what the solutions are. So with a circle, it's really nice to do it algebraically because in circles, it's kind of hard to do it graphically unless you have a really nice circle. It's hard to see where the points are. That's the tricky part. Okay? So what I want to do is I want to do a substitution. I'm going to try to use substitution here. So I'm going to isolate something here. I'm looking at the bottom equation. You're never going to isolate. You're not going to do the circle. That's never going to happen. It's always going to be the other one. because it's hard to isolate here because you're going to have square roots, right? So I'm going to isolate this. I'm going to move 3y over. So I'm going to have x equals 3 plus 3y. All right, and now I'm going to substitute this x into the other equation here. So it's going to look like what? I'm going to try to write small here. It's going to look like 3 plus 3y squared plus y squared equals 9. Okay? Don't forget that you have to distribute here. So I'm going to take it over here and let's do it together. Just a little review. 3, this is double distribution, right? Times 3 plus 3y. So we're going to do 3 times 3 is 9, plus 3 times 3y is 9y, plus 3y times 3 is 9y, and plus 9y squared. Okay, so I do a little simplifying here, and I get 9y squared plus 18y plus 9. So that's this piece here. Okay, so I'm going to bring it back. Here we go. 9y squared plus 18y plus 9 plus y squared. Don't forget, that's the one that was there before, equals 9. So now notice that I have two common terms here. I have 9y and y squared, so I'm going to combine them. 10y squared plus 18y plus 9 equals 9. All right, so now I'm trying to factor this, so I want to simplify as much as possible. Okay, so if I'm trying to factor this, and I need to set this equal to 0, so I'm bringing the 0 over, or I'm going to bring the 9 over here, so I'm going to do minus 9 on each side, right? So then I'm left with 10y squared plus 18y plus 0 equals 0. All right, now I'm checking to see what would be the best factoring method here. I can do sum product. I can't do AC because there's no C really. So what I want to do is I want to do GCF. So I'm factoring out 2y, and then inside I'll have 5y plus 9 inside the parentheses. Okay, now I have two factors. 2y equals 0. 2y equals 0. So then y will be 0. When y is 0, what's going to be my x? Well, again, you go back up here, and then you're going to plug it into a nice equation. Either one of these two will work. It doesn't matter, but this is a nice one. So if I plug that y equals 0 back into here, into this equation, what will I get? I don't know. Let's check. X equals 3 plus 3 times 0. Okay, so x equals 3 plus 0, which is 3. So my first solution point here is going to be 3, 0. Let's take a look at the other guy here. So that was one of the factors. Here's the other one. 5y plus 9 is 0. So I minus 9 from each side. 5y is negative 9. And then divide by 5. Y equals negative 9/5. Okay, so here's my second y. Now what will be my x? Let's plug it back into the equation there. So x equals 3 plus 3 times negative 9/5. Okay, so I'm going to do what here? I'm going to need a common denominator in a minute. So this is going to be negative 27/5. When I find, let's take this up here a little bit so you don't run out of room. I need to find a common denominator. It's going to be 5, isn't it? Because this is over 1. So if I use 5, then I have to multiply the bottom by 5 and multiply the top by 5 to get that common denominator, right? So then I'm left with what? X will be, the common denominator is going to be 5, and then what will I have here? I'm going to have 15/5 15 minus 27. Okay, so when I do that, I get negative 12 over 5 when I do a little subtraction. So that's my second x. Okay, so my first point is 3, 0. My second point will be negative 12 fifths, comma, and what was the y? Not negative 9 fifths. And this is a point, so let's not forget the parentheses. Okay? So this is what I mean by not a nice point. That's not a nice point. So it would be practically impossible to do this graphically, right? So that's why we need to be really good at knowing how to solve them algebraically as well. Let's take a look at the next one. Okay, so for the next one, I do want you guys to check this one. So let's show you some techniques for checking. So we have y squared minus 2x squared equals 6 and y equals 2x. Look how nice that is. Y is already set to equal negative 2x. So we're going to plug that. We're going to sub this back in here. Okay, so what's that going to look like? Oh, it's going to be negative 2x squared minus 2x squared equals 6. So when I square that, I get 4x squared minus 2x squared equals 6. So I can combine this because they're like terms, and I'm left with 2x squared equals 6. Divide by 2 on both sides. X squared equals 3. So then x will be positive or negative radical 3. So there's two x's here, right? It's the positive and the negative of that. I need the y. So I'm gonna plug it back into either one of these. Let's plug it into the one on the bottom. It looks a little nicer. So we'll do y equals negative 2 times radical 3. So then y is just going to be negative 2 radical 3. So the first solution here is going to be what? It's going to be, the x was radical 3, so radical 3, comma, negative 2 radical 3. Okay, that's my first point. And then the second one here, same equation. Y equals negative 2 times, but now it's negative radical 3. So then I'm left with positive 2 radical 3, because it's a negative times a negative. So the other point, my other point is negative radical 3, comma, 2 radical 3. All right, so now let me show you guys how I want to see you guys check. It's really important that we check. So we're going to come back here, and I want you guys to always make a 4x4 table. I'm sorry, 2x2. A 2x2. Okay, so we're going to start like this, because if there's two solutions, you can do this. This is a really good technique. Okay, so we're going to list the solution points up here, just like what we did before. So radical 3, what were my points? Radical 3, comma, negative 2 radical 3. And then negative radical 3, 2 radical 3. Okay, so now on this side here, I'm going to write the equations. So y squared minus 2x squared equals 6, and then y equals negative 2x. Okay, and now I'm going to plug them into each of the points to make sure that both of these are point solutions for this guy here. Okay, so let's go ahead and do it. So it's going to be, so what's my y here, this guy? So it's going to be we'll do negative 2 radical 3 squared minus 2 times radical 3 squared equals 6. So the question is does that equal 6? So let's go back up here. If I square a radical like this, what happens? Or radical, so you square the coefficient and then you square the actual radicand of the radical here. So this would really turn out to be what here? it would be positive 4 times 3, which is 12. And then what's radical 3 squared? Well, the radical and the square cross or cancel each other out, so I'm just left with 2 times 3, which is 6. So does this side equal that side of the equal sign? Yes, that does. So that works. Let's try with this point here. So we've got 2, what was the y? 2 radical 3 squared minus 2 times negative radical 3 squared. Is that equal to 6 is the question. Okay, so same idea. 2 to the power 2 is 4. Radical 3 squared is 3. So 4 times 3 is 12. So it'll be 12. 12, radical 3 squared is negative. Negative radical 3 squared is just going to be 3, right? So if that's just 3, then it's 2 times 3, which is 12. Sorry, 2 times 3 is 6. Sorry. Sometimes I can multiply single digit numbers. Now is that equal to 6? Yes, it is. So then that point works for, or those 2 points work for that solution, or for that quadratic, sorry, that equation. Let's check the one on the bottom here. Let's check this one. So the question is negative 2 radical 3 equal to negative 2 times radical 3? Negative 2 radical 3 equals negative 2 radical 3, and that checks out. Let's try the other one. Is 2 radical 3 equal to negative 2 times negative radical 3? Well, let's check. 2 radical 3 equals negative times a negative is a positive, so 2 radical 3 checks out. All right, so that's a really good technique there. Okay, let's try number 5. I don't want you to check here, so we'll find the solutions. Okay, so this is a nice substitution example because I'm taking this guy on the bottom and I'm just going to sub it back on top here. So what is that going to look like? So this guy will go here. It's going to look like 2x plus 1 equals negative x squared plus 2x. Combine this to see if we can maybe do some factoring. So we're going to take, we want this to be positive, so we'll move everything to this side. So we'll end up with x squared minus 2x, all the 2x's disappear, plus 1 equals 0. All right, so now let's see what happens here. If I do minus 1 on each side, I can do some product, right? And I can't do any other type of factoring, so I'm going to try to use the square root method. Okay, so I end up with x squared equals radical negative 1. Oh, there's a radical under, a negative under the radical. Who remembers what to do? Oh, that's going to be an imaginary number, right? So x will be positive and negative I. All right, so now I have 2 possible x's here. So I might get 2 different y's, 2 different solutions, right? So let's do them separately. If x is positive I, then what would y be? Plug it back into these equations here. One of them, the one on the bottom is nicer, so I'm going to use that one. Y equals 2 times I plus 1. So y equals 2I plus 1, or we're going to say 1 plus 2I. Why? Because the general form of this is what we call a complex number. You're always going to see the real number first. So it's a plus bi. You just got to remember that. Okay, so 1 plus, so then we're ready for our first point. Our first point is going to be I, comma, and then y will be 1 plus 2i. So this is what we call a non-real solution or an imaginary solution, right? Let's see what happens when x is negative I. So same equation, right? Y equals 2 times negative I plus 1. Sorry, guys, I'm running a little short on room here. So we'll do y equals negative 2I plus 1, or let's rewrite it the correct way here. 1 minus 2i. And that's my second point. My second point will be negative I, comma, 1 minus 2i. So let me rewrite it for you guys. So here's my first point, and here's my second solution. So I'm going to write it here. So it's I, comma, 1 plus 2i. That's the first solution. And then negative I, comma, 1 minus 2i. Okay? So that's sometimes you end up with imaginary solutions. Okay? They're not always real. Let's take a look at this last guy here. I don't want you to check this one. Okay? So now let's take a look. This is nice. Look, they're both set equal to y, so I can set them equal to each other. So we're going to do 3x equals x squared plus 1. Okay, so let's move some stuff over, see if we can do some type of factoring. Equals 0. Okay, so if I try to do sum product, doesn't work. Sum product doesn't work. Any other type of factoring is not going to work here. So I decided to do, I'm going to just go ahead and do the quadratic. Okay, so let's go ahead and do it. A is what here? A will be 1, B will be negative 3, and C will be 1. So let's plug it in. Here we go. X equals negative B, which is negative 3 will be 3, plus or minus square root of B squared, which is negative 3 squared, which is 9, minus 4AC all over 2a, which is just going to end up being 2, right? Okay, so let's simplify a little bit. 3 plus or minus. Okay, what do we have here on top? It's going to be 9 minus 4, which is 5, so it's radical 5, all over 2. So because I have the plus and minus here, I'm actually going to have two solutions, right? So it's going to be x is 3 plus radical 5 over 2. That's the first x. Or we'll have x2, which is 3 minus radical 5 over 2. Okay, so if I have my x, now how do I get my y? Well, then I go back up here, and I'm going to plug it into one of those two equations. The one on the bottom looks the best to me, so I'm going to plug that x back into there. So y equals 3 times 3 plus radical 5 over 2. Okay, so now be careful with this, because you guys sometimes struggle with this a little bit. Think of this. So think of 3 as being, let's just put like, any whole number has, so it's over 1, right? So think of multiplying two fractions. And think of this, because there's a plus here, think of this as an expression. So it's like 3, what we're going to do is we're going to do 3 times 3 and 3 times radical 5. Okay, so now what do we get when we do 3 times 3? Oh, it's going to be 9. So y is going to be 9, and then 3 times radical 5 plus radical 5. 3 radical 5, sorry. And then 3 times radical 5 is 3 radical 5. And then we'll still have that over 2, because 1 times 2 is 2. All right, so that's going to give me my first point here. Here's my first solution. X is 3 plus radical 5 over 2, and y is 9 plus 3 radical 5 over 2. Okay, let's take a look at the second solution here. Let's use the same equation. Y equals 3 times x. So we're going to do 3 minus radical 5 over 2. Same type of multiplication. We're going to distribute because that's an expression, right? So y is going to be equal to 9 minus 3 radical 5 over 2. And there's my second solution. So we're going to have what? We're going to have 3 minus radical 5 over 2, comma, 9 minus 3 radical 5 over 2. And there's my two solutions. Okay, solution 1 and solution 2. They're both real, but it would be kind of tricky to find algebra or graphically. All right, guys. So hopefully you've gotten this. If not, if you run short on time, just make sure that you look at it, you watch it online. Okay? Hopefully you guys are not too confused. Come see me for extra help when I come back if you are. Okay? Bye.